So the work that I do and the work that my group does can be put under a very broad umbrella of trying to answer the question of how you should allocate limited resources. Okay, so this could be organs, vaccines, food, loans, data, ads. I can put a lot of things under this umbrella, and I'm interested in many of these things. My research is trying to understand how to do this allocation in an efficient, instead of compatible and fair way. So trying to balance these three things: efficiency, fairness, and incentives. Okay, but I'm primarily a theoretician, so I'm a theoretical computer scientist. But I'm not going to show you a bunch of math. Instead, I'm going to ground everything to a specific application, and tell you about the work of my group in that application. The application is food waste. Okay? So the question is, how should we allocate food? I'm sure everyone in this room knows that food insecurity is a problem. But let me spend a little bit of time try to convince you that it's a huge problem. Okay? So in numbers, we waste a staggering 40% of our food. Okay? So this is almost half of what we make we throw away. Sorry, this is in the US. In weight, this is like 120 billion pounds. In terms of dollars, that's like 410, roughly, billion dollars in food thrown away. 130 billion meals. Okay, that's a lot of meals. At the same time, 34 million people in the United States are food insecure. This is defined as, when asked the question, do you have enough food to feed everyone in your family? The answer is no. 9 million of them are children. 50 million people turned to food programs in 2022. And no one is immune. So 100% of counties in the United States have food insecurity in some way. Okay? So this is an allocation problem, right? I'm claiming we're wasting so much food. At the same time, we have a lot of hungry people. So we're clearly not allocating these resources properly. So how is food insecurity addressed in this country and globally? What the question is, how should we allocate food? Okay, obviously. How is food insecurity addressed? There's nonprofits at all scales that try to address this problem. So you might know Feeding America. I believe it's the largest nonprofit in the food space in the world. So Feeding America is trying to solve this problem at a country level. Okay, so it's trying to allocate food from one city to the other. So it's trying to move food across cities. But there's many organizations working in the state level. So Indie Hunger Network is one of them in Indiana. There's organizations at the city level. So up there I have 412 Food Rescue, which is a food organization in Pittsburgh, Pennsylvania. And even ACE. This is our food pantry right here at Purdue. Okay? So the scale of the problem really affects the type of solutions you might suggest as reasonable. Okay? So for the purpose of this talk, I'll talk for the people in the diagonal. Indie Hunger Network and 412 Food Rescue. I'm going to be talking about some of my collaborations with these two organizations. And there's many challenges when you're trying to suggest solutions about the problem. Of course, you want to be efficient. Of course, you want to be fair. The complexity of your solution matters. The scale of the problem matters. Uncertainty about the future matters, and transparency matters. Sometimes, you're limited by the fact that you have to give out a solution that's not just like straight up optimization, but you need to explain what you did to people. And that is limiting as an optimization person. So today, among the many ways that you can suggest to address this problem, I'll be talking about a specific one called virtual democracy. So this is a method that me and my team developed back in Pittsburgh when I was a postdoc at CMU, continuing now across these two collaborations with 412 and IHN. So let me tell you about the problem. Let me tell you very quickly how 412 Food Rescue works, or one of the programs they run. So on the left side, we have the donors. Giant Eagle is a big supermarket. Whole Foods, East End, Einstein Bagels. So these people are one of the many that want to donate food. Okay. On the right-hand side, we have the recipients. Okay. These are organizations, not individuals. Yet again, scale, right? This is not a person. This is an organization that serves actual individuals. So these organizations are the recipients of the donations, okay? The Starvation Army, community food banks, and so on. And 412 sits at the middle. So this is the program they run. When someone wants to donate food, they call 412 Food Rescue. 412 identifies a recipient and dispatches a volunteer. So 412 has a very interesting program they run. It's like Uber. You can download it on your phone. And it will notify you, hey, do you want to go from place A to place B to drop this off? And 412 uses the app to communicate with the volunteers and sends them over to the drop-off. Okay? Fantastic. Where's the problem? Very quickly about the Indie Hunger Network. Indie Hunger is very similar, only that the food comes from truck drivers. So the food, one of the programs they run, a truck driver tries to deliver, a truck full of pallets with, tens and hundreds of pounds of food, avocados, and the top pallet is bad, but everything else is fine. But Walmart says, I don't want this. And now the truck driver has a bunch of food that their outside option, this is what they do, or what they did before this, is to go and dump it. Okay. So IHN is trying to rescue this food. So it works with our truck drivers trying to get this food to recipient organizations. You might recognize Food Finders. So Food Finders is one of the recipients in this scale. Midwest of Indiana, Gleaners, and so on. Okay, very similar programs. Again, truck driver contacts IHN. IHN delivers a recipient and tells everyone what to do. Okay, what's the problem? The problem is the humans, as it turns out. With 412, this is a lot more apparent. But as it turns out, if you have a human talking on the phone, making 1,000 decisions a day, the statistics of the allocations they produce are very predictable in a bad way. So specifically, perhaps as you can guess, 90% of the things go to 10% of the recipients. Right? Think of who you rely on for stuff. Yes, it's a small list of people. Even though there's 200 recipients, top 20 gets most of it. So our goals in these projects were to automate the matching process. Okay? That's our goal. And of course, in doing so, not only do we need to worry about standard speaking optimization things like driving distance or something like that, we also need to ensure fairness. So we need to make everything democratic with respect to the recipients. And in fact, part of the constraints of the problem when given to us was to take into account everyone's preferences. So for 412 specifically, we wanted everyone to have a say. So we wanted to predict what volunteers want, what the 412 employees want, what the donors want, what the recipients want. Okay, so we want to be democratic in a sense that everyone's opinions is taken into account, because that's what the human was claiming to do. And of course, we want to be transparent. Okay, so I'll be showing you how to build a recommendation tool, not a matching algorithm, in a sense that we're just going to give a human, the human who makes the decision, a recommendation of what should happen. And we also need to have a way to explain to them why we're recommending what we're recommending. Okay, it won't just be ChatGPT said this. Okay. Good. I use the word democratic for a reason, and the reason is to make you perhaps think of the solution, or make the solution sound more reasonable, or easier to come up with, which is voting. When we think of democracy, we think of voting. So in an ideal, perhaps, world, what you would like to do, if you want a democratic system, where not one person makes all the matching decisions, is to just ask everyone to vote. Okay? So everyone who you care about, recipients, donors, employees, volunteers, everyone. So everyone casts a vote. Right? And what's a vote here? A vote is a ranking. A vote is a ranking of the alternatives. What's the alternative? The recipients. So a very expressive vote you can ask for me is, I think the Salvation Army should get this. That's my top choice. My second top is Meals on Wheels. My third top is the YMCA. That's what I think. Okay? So you can elicit votes from everyone, and then aggregate these votes into a collective decision. Okay? So burrito comes, everyone votes. Pizza comes, everyone votes. A burger comes, everyone votes. Okay, so obvious issue. You need to have these interactions like 2,000 times a day for the scale of 412 food rescue, which is obviously ridiculous. Good, and that's where we come in. So what does virtual democracy try to do? Predict. That's step one. What if we could predict what people vote? Okay, that's the main idea. So the steps in virtual democracy go as follows. First, we'll collect data about what people's preferences are. And then we'll try to build a model that predicts what people prefer. And then at runtime, when I need to make an actual decision, instead of aggregating real votes, I'll aggregate predicted votes. Okay. That's the high-level idea. So the motto is learn models for people and let the models vote. Okay. Questions so far? Good.
Do you ever get enough data where you can actually make the decision in real time rather than trying to get everybody to vote every time on what needs to be done?
I am making the decisions in real time. I collect data from you once, and then I build a model for you that I will use in real time. Perhaps, hopefully this becomes clear as we go. Okay? But this is the 3 steps of virtual democracy. So this is the virtual democracy we defined is a more refined version of a similar pattern defined by a different paper by Nuthikatu et al. For self-driving cars, of all things. So the idea here, perhaps you remember this discussion when self-driving cars were at the top of everyone's mind, was you have a self-driving car, it's about to get in an accident, should it save the driver, or should it save someone else? So it's so really the virtual democracy framework is a refinement of this framework that had extra steps. Good. So let's see virtual democracy step by step and how to apply it for addressing 412 food rescue's problem and IHN's problem. So what was the data collection step? First, we identified all the features that are important for decision making. So if I ask you, our HCI collaborators went out there and interviewed all the stakeholders and figured out all the things that are important for their decision making. So these things, I don't know if the slides are clear, but travel time was important to say the volunteers. Last time the recipient received a donation, the size of the recipient, the poverty level in the area of the recipient, the income level, how many donations they've received in a certain window, these sort of things. Okay? So we identified all the important features. And then what's a piece of data? I give you a feature vector, and I give you another feature vector, and I ask you who should get this donation, A or B. Okay, so this is a toy recipient A with a specific organization size at a specific distance from the donor that received the last donation at some a week ago or never, and recipient B is a different feature vector. And I ask you, do you prefer A or B? That's one data point. Okay. Unfortunately, we can only get very few data points. So to get 50, we need to sit someone down for like an hour. So data was somewhat limited in our application, and we could only do this for 25 of the hundreds stakeholders. But we did it. Good. Let's have a data collection step. Sorry, this is zoomed in. This is, so A or B, A or B, A or B, 50 times. So now we have our data. So now we need to do learning. Now I want to have a model that predicts your preferences. So I want to have a model that I can see and check that is consistent with the things that you told me. Okay. Slightly more on a technical level, what we do is we assume that in reality you have some utility for an alternative. In your mind, there's some value you assign to the donation going to a specific recipient. So I just need to find out what these utilities are. Okay, and as it turned out, linear utility functions did well. And also, as it turns out, it was computationally infeasible for us to learn anything more complicated. However, we had pretty decent accuracy on the data. So at runtime, right, we ask the model we learned for someone, what do they think? And the model gives us a ranking. Right, so step one, we learned the models of the voters. So I replaced the green person with the green machine, the red person with the red machine, the blue person with the blue machine. And now I ask the machine, what do you think? What do you think the opinion is? And our guarantee, the probability that I got a pairwise comparison right, is something like 90%. Okay, on the data. Make sense? So I collected data. I learned models of everyone, of every single stakeholder. So now the question is, what do I do with these predictions? Right? How should I aggregate them? So let's see the aggregation step. The framework to be thinking about this sort of aggregation is voting. Okay? It's a very rich field, social choice, that tells us how to do these things. However, as opposed to traditional social choice, here the predictions are noisy. We don't have actual votes. We have predictions of votes. So that should affect our choice of voting rule. So what we would like for our voting rule to behave the same on the predictions as it would on reality. So in a sense, we desire some kind of robustness with respect to noise. So the technical question, this is more of my day-to-day life. The technical question we ask is which voting rules have the property that their output on true preferences is the same as their output on predicted preferences. Okay? Which voting rules are robust under noise. So again, on the left, we have the hidden true votes. On the right, we have the observed noisy votes, and learning is in the middle, trying to take us from one to the other. Okay. Malus noise is a technical term for the type of noise we assume. Right, so we apply a voting rule on the left, and it is some kind of recommendation or some outcome. If you applied your voting rule on the left, you'll get that A3, recipient 3 should be first in line, and then 1 and then 2. And when you apply it on the noisy votes, you might get something else, but you don't want it to be too different. Okay. Good. So let me tell you about some voting rules. I guess probably the two voting rules is majority and maybe the, what is it called, ranked choice voting. But there's many. There's tens of voting rules. Let me tell you about Borda. Borda is what we use for Eurovision. If you're from Europe, you might know. So Borda was as follows. The ith voter will give 0 points to their worst alternative, and then 1 point to their second worst, all the way to the top. Okay? So going down up. And then once you have all these points, you sum them up, and you put first the thing with the most points, and then second the same thing with the second points, and so on and so forth. Okay? So here, in this toy example, there's 5 voters and 3 alternatives. Voter 1 will give 2 points to A, 1 point to B, and 0 points to C. Voter 2 would give 2, 1, 0, A, B, C. Voter 4 will give 2 points to B, 1 point to C, and 0 points to A. And then you add up all the points. Okay? So our informal theorem is that Borda is, in fact, robust under noise. So with high probability, Borda will not make a mistake. While at the same time, there's a huge family of voting rule that does. Okay? Without speaking any more technical stuff. Okay? Borda also have this non-technical bonus point that is very easy to explain. If I want to explain to you why Borda did this, I just need to tell you about points and adding up stuff. So in our recommendation system, we did go with Borda. So here's what we built for them. This is a map of Pittsburgh. And this is the real-time thing that happens when you have a new donation. Okay, and on a pretend the names of the recipients are fake. So this is our recommendation. First, Green Fire, then Hidden River, then Divine Frost, then Blue Fire. Okay? This is the ranking we suggest the person follows in contacting these recipients to see who wants the donation. There's various things to observe. So that's a map of Pittsburgh. But we can explain why that's the outcome. Okay? So we can use the features as a means to explaining what's happening. So I'd like to draw your attention to first, unlike other decisions, like policy decisions or something, now I have very concrete features that I can work with. And we can use this to explain. So for example, the justification here would be something like, the driving distance is so short, it's been so long since they received the donation. I can use this feature as a way to justify my recommendation. And the other is I have the scores. So I can use the Borda score as a way to show you how close 1 and 2 or 2 and 3 or 3 and 4 were versus just a straight up list. Okay, and you can also break it down to stakeholders, right? So 412 ranked this as 5th. The drivers ranked this as 1st. So you can use all these ways to help explain the outcomes to a person. Okay, that's all I wanted to say about the 412. So, a big issue in doing all this and was, of course, data collection, and our computational limitations. So, with RCAC's infrastructure, now we can, of course, be more ambitious in the size of the models we can train. So for the 412 project was done in someone's laptop, for example. But of course, more broadly, something I'm very interested in is applying this framework into domains, beyond food. Okay, that's all I have. Thank you.
There's such a problem with, you've got all these food groups, people that need food and are going to distribute it, and on any given week, they have trouble getting vegetables, or they have trouble getting milk, whatever the thing is. I'm curious, what has been the user satisfaction of the two organizations, of the Indie Group and the 412, in terms of the data that you've provided? Have you been able to get the food to the right places and really get the people fed?
Good. That's a great question. So the Indie one is under progress. So like I'm hoping to send out the email to them like everything is ready. Please point your website to it like this week or next week. The 412, I've dropped the slides that have the feedback from the users. I can share them with you if you send me an email. But people like it. In fact, like the whole process had this very interesting, to me at least, side benefit of it increased people's trust in AI. It made it seem less magical. But people are overall very happy, and more importantly, like for something measurable, the thing we initially cared about, 90% of the donation going to 10% of the people, that really got smoothed out. So a lot of food went to places that were really starving for donations, at least from the point of view of 412. Okay.
A comment and a question over here. Not a question. Anyway, interesting talk, really, from technical point of view. A way to solve a problem if you want to apply AI to it, obviously. Unfortunately, it sounds to me more like a solution in a need of a problem rather than a problem which finds a solution. Biggest criticism here, in this way, you are distributing only the excess food which is available from the sources. You are not addressing at all the bulk, which is the majority of the food which is being distributed in this country. And because of that, even at best, this can only be a partial solution. I mean, technically, again, excellent. I just want to remind everybody that there are other solutions to these problems which are much easier. And the obvious one is you stop subsidizing food production, start selling food at its real price. This makes food expensive. You collect more taxes, you being the government, obviously, in this case. And then you give money to the people who cannot afford food so that they can afford food. And this solves the problem.
Let me address the first point of a technical solution needing a problem. I mean, the problem is there. Someone picking up the phone 2,000 times is a problem. That's a problem. Indeed, we didn't change our input. Yes? Various organizations trying to address food insecurity at various levels. Of course, we can, shift everything and say this higher authority should just solve it for us. But the reality of the situation is that people are hungry. And these organizations are making actual steps within the domain allowed by law to solve it. Having the discussion of maybe the law should do more and is obviously a very valuable discussion to make. At the same time, we're actually feeding people here. So,
Thank you. I love that. Any other questions? Right. Thank you very much, Alex. We really appreciate it.